say you were making boiled potatoes, and the traditional way to do it would be to you take your potato, you wash your potato, you peel your potato, you boil your potato. You grab the next potato, you wash it, peel it, and boil it. And then I said, but in Q, or in these array languages, you would wash all your potatoes, peel all your potatoes, boil all your potatoes. And he said, oh, great, that's I get that. That's really helpful. And then I said, but wait, there's this other level that I don't think I'm at. It's like I'm striving to get there. That's why I keep pursuing this. Is like there's this other level where you boil your potatoes and you filter it for skins and dirt.
Welcome to another episode of ArrayCast. I'm your host, Conor, and today with us we have a special guest who we will get to introducing in a couple minutes. But before we do that, we'll go around and do brief introductions. We'll start with Stephen, then go to Bob, then go to Rich, and then to Marshall.
I'm Stephen Taylor, APL and Q programmer.
I'm Bob Therriault, a J enthusiast.
I'm Rich Park. I'm a APL teacher, evangelist at Dyalog Limited.
I'm Marshall Lockbaum. I'm a former J programmer and APL developer, and now the BQN developer.
And as mentioned before, I'm your host, Conor, a research scientist at NVIDIA, C++/other languages, but huge array language fan. And we will get to introducing our guest, who I'm super excited to talk to, just after a couple short announcements. So I believe we have 3 from Rich, then 1 from Stephen, and then 1 from Marshall.
Yeah, so I'll go in order from closest to now to furthest away. So those of you who know or don't know, Adam and I have got another podcast because you can never have too many array language podcasts. But we've rebranded as the APL Show, so you can go find out about that on apl.show. And yes, the availability of that domain name was part of the decision to to call it that. And it turns out in searching, actually, we're now on a bunch of other services that we finally figured out how to get the RSS feed coming out of GitHub pages. So we're on Spotify, Simplecast, Google Podcasts, Samsung Podcasts, iTunes, Apple Music. It's unbelievable, isn't it, Bob? We actually managed to do that.
Rusty's joined the club. It's a podcast.
It's actually a podcast, but we're calling it a show because we're contrarian. So, but that's available now, and the latest episode where we ramble about some sort of higher level stuff about notations for describing structures and diagrams and things like that is out on apparently everywhere now, everywhere where you can listen to or watch things.
What's the name?
It's the APL Show.
The APL Show.
At apl.show.
Connor's not happy.
I'm literally on my cell phone right now searching for this on my app.
I mean, literally, this is like yesterday or the day before. So
it might not have updated. This is big news.
Like, I've gone on iTunes and I have to filter down to podcasts to find it. It just doesn't come up in the. This is too much detail about the other podcasts. For
the listener, though, by the time you hear this, it will probably be up because that'll be another 3 or 4 days before it'll be on.
Okay, yeah. Going further out into the future, March 12th, there's not been one of these in quite a while, so listeners might not be aware of what this is, but Adam used to host a fairly regular sort of live Zoom panel with various figures from array language life and history called the APL Campfire, and there's going to be a special return of the APL Campfire on March 12th with Norman Thompson, who is the author of APL Programs for the Mathematics Classroom and the co-author with Ray Polivka of the book APL2 in depth. So we'll link to the APL wiki page about that in the show notes, no doubt. And then lastly, just another shout out for March 22nd, so that'll be 10 days after, APL Seeds 23 online meeting, which is an event hosted by Dyalog to enthuse people, new and prospective APL users, people who might have heard of APL but not really know much about what it's about. Come see a few talks and talk to a few APLers. The sign up is not ready as of speaking right now. Hopefully by the time the episode comes out. Otherwise, there will be a link to the Dyalog webpage, which will be updated with registration information as that happens.
So many things I just learned about. Wow. All right. Appleseeds 2023, the APL Show, and Campfire, of which we will talk about after the show. You should put that stuff on your podcast. All right. Over to Stephen, though.
Well, we've fantasized on this podcast about ArrayCon, a conference for the array programming languages, and that remains a fantasy. But this year there will be a KXcon, and it's in Montauk, New York, 17th to 20th of May. I've got no details for you at this point. I'm just forecasting massive.
All right, awesome. We'll look forward to more details from that. Man, we're getting all the announcements that I didn't know about. All right, and finally over to Marshall.
All right, so my announcement, you may know that BQN uses a self-hosted compiler that's written in BQN. And this means that in order to run the compiler, you compile the compiler and then you have bytecode which your BQN VM runs. Now, this requires you to start with a compiler that's working. So what happens in practice is that actually we just compile the compiler for you and give you the bytecode for that, which is not good for a number of reasons. And a lot of people object to having this, you might call it a binary. It's not really binary, but it's bytecode that you have to just take from us and trust. So what we have now that we've done is to build up a chain to compile a compiler without relying on any precompiled stuff. So what I did was take the compiler, simplify the syntax some, but make sure it can still compile itself. And then I did that a few more times and got down to one with very simple syntax that I then mentioned, and Zyma then spent a day writing a compiler for it in C that works. So CBQN runs that very simple compiler and builds up this chain, and you get the full one. And I don't know if it's set up to do that automatically, but you definitely can now download the CBQN repository and the BQN sources and build your own compiler and compile the full one and verify that the one that we give you is actually the same. And the other neat thing about this is that actually I have another BQN compiler that's equivalent to that simple C compiler. Some minor differences that I verified don't do anything to the performance. And the BQN one is actually twice as fast. So that's kind of cool. So that's the announcement. No big changes for any BQN users, but just an interesting thing that we did.
BQN leaves the nest and enters the wide world.
Well, it was the first array language to ever self-host. So there is that. Only one as far as I know.
For now. Well, we got decades ahead of us. So, all right. Well, that's all of our announcements. Be sure to check out the show notes for links to all of that stuff. Definitely the other APL podcast. But now we are going to introduce our guest who's been waiting in the wings. I'm super excited about this conversation. You've probably already read the title of this podcast, so you know today our guest is Michael Higginson, who, if you follow I'm not sure, there's two different Dyalog channels on YouTube. There's Dyalog Limited and then Dyalog Conferences or something. We'll put links to both. But Michael gave a talk that I think was released around October, November of 2022. So if you're listening to this live, that was 2 or 3 months ago. And he was the winner of the professional entrant in the Dyalog APL contest. So for those of us that don't know, or those of you that don't know, it's a student contest, and I think you have to be enrolled in either a college or university across the globe, but you can still compete even if you are not a student, and there is a professional sort of category, and you can win that. And Michael was the winner in 2022. So a little bit about Michael. This is in his own words, and this is on a blog that we will also put in the show notes that sort of talks about the winners of the contest. Immediately after receiving my bachelor's degree in computer science from the University of Toronto, so fellow Torontonian here, I joined a small company founded and populated by a number of ex-IPSA, that's IP Sharps and Associates, employees. I had a great time there and stayed for over 20 years. For most of those years, I didn't know anything about APL, except that it was different, that it used a non-standard character set, and that it was held in some reverence by my mentors and colleagues. But around 2013, I started working with the Q programming language, and after a few battles with it, experienced a profound, quote, mental click, end quote, that irrevocably changed not just how changed not just how I think about programming, but most other areas that I turn to my mind to as well. As I was curious about other languages in the family and looking for a new challenge, I decided to use Dyalog Contest as an excuse to learn APL, and it was a great experience. So I had the pleasure of meeting Michael back in September when we held the Toronto APL meetup. So it was awesome getting to chat with him a bit there, and I'm super excited to have him on the podcast. Thanks for being here, Michael. And maybe you can, in your own words, once again, take us back to however far you want to go back and, give us a little bit more detail about your journey to Q and then I guess to the APL contest.
Sure. Well, thanks everyone for having me. It's great to be here. I guess the traditional starting point in this journey is usually your first computer. And so in that tradition, I will let you know that my first computer was a Commodore Vic 20 that I received as a Christmas gift as a little kid. And so the Vic 20 was a small computer where the computer and the keyboard were sort of just one object, and it had 5 kilobytes of RAM. And for storage, it had a cassette drive. Wow. So it would take an audio cassette, and you could, you'd issue a command to the computer to load off the cassette player, and it would say press play on tape, and you would play, and then you press the play button, and then being a little kid, I think I'd jump around the living room or whatever to and wait as the cassette played, and then it would load the program. And I think any member of a generation that had a computer in the house as a child, the gateway to computing for me, of course, was video games. And that's really all I did on it. This was not the computer that I learned to program on. Although I had heard, there was a rumor in the school ground that you could go to the library and take out a magazine. I think there's a magazine called Compute, and maybe there were others. And in that magazine would be the listings for what would be a game. So basically, you could go to get this magazine, and there'd be a basic program on the pages of the magazine, and you could type it in your computer, and then you could play a game. So this was very exciting to me. So I did that, and sure enough, it was there. But when I went to type in the program, every time there was an asterisk, for a multiply or whatever, when I typed it into the Vic 20, it would be this big, fat, 6-pointed asterisk that took up, a whole character width. And the asterisk that was printed in the magazine was a tiny little 5-armed asterisk that was sort of up high. And they looked so different to me that I thought, well, that can't be right. So I left them out. I thought, well, I don't want to put in the wrong character. So I left it out, and this seemed epic. I'm sure it was just a couple pages, but for a little kid, this was like a major operation. And so at some point, I managed, I got the thing to run. Like I hit run or whatever, and the screen came up, and I thought, okay, great, I did it. And then I think you were supposed to be a guy who could fly around the screen or something. And at the moment I tried to input something, of course, I got a runtime error. And that was very disappointing, and I sort of moved on. Although I often think if I had someone in my life who knew more about this stuff and had said, Michael, the game is actually to fix these errors, I wonder, maybe if my life, how it would have played out. After that, I got a IBM and XT clone, so I was sort of in the world of PCs and DOS and a 386 or whatever. And at some point I got a modem, and that was a real eye-opening experience once learning that these computers could talk to each other. And this was sort of pre-internet, but there were local things called bulletin board systems, and it was sort of like the internet, but only one person could be on it at a time, but you could leave messages for each other on there, and certainly some of my oldest friends still to this day are people I met through those systems. So I wasn't a programmer, but I was a computer user basically, and so I got to high school, and my high school did co-op placements with businesses and organizations, and I guess
what really?
Yeah,
your high school?
Yeah.
Wow, that is like you don't hear about that until university days. That's an impressive feat for a high school.
Yeah, it was sort of interesting, and I guess what had happened was that the high school had placed a student in a government ministry here in Ontario, and to help to be a co-op student on their help desk, on their technical support team. And I guess, I don't know, maybe they didn't know what to do with him or whatever, but I guess they gave him some manuals for the system. And I think ultimately what he had done he'd found out basically a way to send a message to every user in the system, which was like every employee of the ministry, so that like some sort of strange cryptic message that said something like, "I am watching you," or something like that came up on the screen of every employee of the ministry. And basically that didn't go over well, and they wanted the school, and so he sort of lost his placement, I guess, over that. And I guess the school wanted to smooth things over, and so they went to me. I guess I was kind of smart and personable or whatever, and so they sent me in to replace him and as to give a better impression. So I did, and so that was sort of my kind of first technical job. I remember one of the projects I had to do is I went around and I had to install 486 upgrade chips into the the workstations being used by some of the programmers in the ministry. And I kind of remember these programmers, I thought of them as these sort of super beings. Like, I knew how to use a computer, but they were doing something totally different than what I was doing. I'm sort of, I know how to, I don't know, resize a window on Windows, which, by the way, was an application, not an operating system back then. But they were just doing something really different. And what was sort of interesting to me is that they were sort of, in a way, they were like these super beings in that they could get a computer to do so many things. But in other ways, they didn't know how to administer their own system. Like, they kind of didn't know how to use a computer, but they knew how to program one. I thought that was really interesting.
Some things don't change, do they?
Yeah, no, I ended up being one of those guys. So anyway, so I did that job, and then, and then they extended, they gave me a summer job. So they asked me to stick around over the summer. So I guess I repaired the relationship between the school and the ministry. So I guess that was mission accomplished. And so then I get to university. So University of Toronto, and I didn't really know what I wanted to do. And I took a bunch, I took philosophy and psychology and Greek and Latin but I took Introduction to Computer Programming, because I thought, well, this is something I ought to enjoy. I do, like computers, and I see their value. So I took this course, Introduction to Computer Programming. I had a great teacher, and he, we were programming on the blackboard, but the way he showed how to, we would take whatever problem we were trying to solve, whatever it is, I don't know, bubble sort or something like that. And I think, okay, I sort of understand the problem, but I think, how are we going to solve that? I just wouldn't know how to solve it. And, we have this, and basically he would start just writing on the blackboard, like the things that we, at a high level, the things that we're going to need to do to solve this problem. Like, I don't know, we're going to need to create a list where we're going to, put the results, and then we're going to, take two of them and compare them or whatever. He would just start writing down at a high level, just paraphrase in English, the steps we're going to do to solve the problem. And then we would convert those into code. At the time, it was Turing, which was an educational language developed at the University of Toronto. And then the bits, the fragments of English that we'd use to work out how we were going to solve this problem, he'd say, and then you leave those in as comments. Maybe you clean them up or whatever, but you leave those in as comments. And something about this process for me seemed so like soothing. Like and I basically realized, you've got this, programming to me is you take this empty text file and you just start putting your worries and your problems into it. And then you refine them and you refine them and you refine them. And what you end up is a program a well-commented program that solves your problems. And there was something about that process or that approach to programming that just really clicked with me, kind of made order out of chaos and confusion. And for whatever reason, that's what made me say, okay, I know this is what I want to do. And then one of the courses I took was called Natural Language Processing. And that course was done in Perl. And I kind of don't remember too much about really Perl or the domain of that. I know a bit, but I remember one of the things that struck me was that Perl had this regex operator, like a regex matching operator as a built-in, not as a function or whatever, but just as a syntactic piece of the language, and it was so well suited to the problems that we were solving in the course or whatever, and so that stuck with me. I never really became a Perl expert, although Perl, and I ended up using Perl sometimes to solve one-off problems in my programming career. So I might mention that later. So basically, I got exposed to some languages, but C was really the only one I came out of with some competency at a school. But in the summer between third and fourth year, I got a job as a research assistant at the AI lab at U of T. Which probably sounded more glamorous than it was, but I was a Java programmer now, and we were building a visual knowledge modeling tool in Java, and so this is my first programming job for sure. And there was a guy there who I think he was the original author. He was certainly the current maintainer of the program, and he was another student, and so we got introduced, and I can't remember exactly how he started me off, but you don't get too far without needing to either create a source file or open one up and read it or whatever. And so he's with me and he says, okay, open up this file or whatever. And so it was a Java source file, and I opened it up in Notepad, and he said, like, whoa, wait a minute. Like, we're not going to be working in Notepad all summer, programming in Java. And so he sort of sat me down and he was a Vim user. So he started teaching me Vim, and so he was sort of the guy who started putting programming tools in my hand, not languages, but sort of the tools around the languages, and we and I started forming opinions on syntax highlighting or whatever, and so that was kind of a really fruitful time. And we did a bunch of pair programming that summer, which was just, if you've ever done a lot of pair programming with someone whom you're on a wavelength with, it's just kind of a magical experience. It's just fun and motivating and an incredible way for knowledge sharing, and it's really a lovely human experience to do that. And so it's fourth year now, and now I need to. It's the end of undergrad is coming, and I need to find a job. And so through just kind of, random luck and a networking phone call, a friend of my mother's had worked at a company and thought it was a good place to work or something. And so he sets up a phone call for me with a guy named Leslie Goldsmith, who worked at a company called Affinity Systems. And he and a guy named Hugh Heinemann had founded this company. It was a small to medium software consultancy in the Toronto area. And Hugh and Leslie had worked at a company called IP Sharp and Associates, which I'm sure everyone on the panel knows, and most of your listeners know. But IP Sharp and Associates was a sort of a worldwide company with a heyday in the 70s, I guess. And they were a timeshare company, which is sort of pre-internet cloud thing. And they built applications for customers. And so they were a consultancy, and they did it all in APL. And they had their own flavor of APL, and a bunch of luminaries from the field worked there, including Ken Iverson, and after he left IBM, and Arthur Whitney, and I think even a panelist on Arraycast might have worked there.
I was regarded, Leslie, as one of the luminaries.
Well, so did I. Obviously, I didn't work at IP Sharp and Associates, but Hugh and Leslie had worked there, and there was this crew of other people who had worked there too. Guys like Mark Dempsey and Dave Markwick and Raj Chauhan and Heather Bowen. She may have come from Reuters after the acquisition. I'm not sure, but there was this crew of folks that had come from IP Sharp and Associates. And so I joined this team, and they'd been working together for 10 years at Affinity Systems, and some of them for 15 years or so before that at IP Sharp and Associates. So some of them had been working 25 years together by the time I got there. So I was really kind of slipping into an experienced team building, really interesting and challenging projects. And so, like the first project I started on was an online trading system for day traders, and so the first piece that I built in that was the monitoring system for the back end of this thing. So, like a centralized process and a little bit of library or whatever that would sit in all the other processes and report to them. So it was a great, sort of bird's eye view of a complicated system, and a great way to sort of get my feet wet. And keep in mind here, this was in C++. I'm learning C++ on the fly. I've never seen an IDE before. So, I was using Vim and source files before. I think this might have been my first exposure to source control or whatever. I didn't know what a memory leak was. I remember Leslie one time, I was demoing something I built on, and that the demo went well or whatever. And then I stopped the application, and he said, you've got memory leaks, because, at the bottom of the console of the IDE, all these, memory leak warnings came by. And I was, at this point still like, oh, I got to look at that stuff. So I got that kind of monitoring system off the ground, and then I had to do a little bit of a refactor, and so that was sort of interesting, going in and touching other people's code. And then the next thing that needed to be built was what we called the quote server, which was sort of like a feed handler. It was basically the piece of the system that receives all the real-time market data from a market data vendor and shuttles it to, normalizes it and shuttles it where it needs to go or whatever. And so it's, it's a high performance, real-time application, and and that data is, really critical to this trading system. And so, I'm not sure, if most companies, that needed to build one of those would say, well, let's give it to the kid who doesn't know what an IDE is. But I do think that maybe at IPSA, that is what they would have done. And so, the culture at Affinity Systems, which I think was sort of modeled after the IPSA culture, was, we'll give it to the kid, basically. And so that then became my project. And, and it's not like I was alone. I had some really, really smart people that wanted me to succeed and were, going to help me do it. But from that point on, I became the market data guy. And so I built that application, and then we ended up doing a similar project just after that, which was not aimed at traders, but making market data, real-time market data, available basically to consumers. And we were doing that for a major newspaper in Canada. And this, we were streaming real-time quotes over the browser to Java applets over the browser in 2001. So this was, I think, kind of state of the art at the time. And then we had to, and all this market data problem grew, and we started including options data and level 2 data, and having to construct a level 2 for the Canadian exchanges, which was based on an order book. But I wasn't just the market data guy. There was, so much variety. The types of projects that we did kept changing. The next project after that, I think I was writing a device driver, and we had some piece of, robotic equipment for whatever. And I had to, install port sniffers and figure out how to drive this thing. And then the next project after that was in Java, and we had to build this, I don't know, sort of a general application framework, almost sort of microservice architecture kind of thing. And I could talk a lot about it, but it was really interesting and detailed. And I remember switching to Java. It had been many years since I had done Java, and the attitude was like, don't worry about it. Like it's the same. Like it's all the same. And as we subsequently went on and had to do a C# project dealing with private health data or whatever it was, like, oh, it's the same. C#, it's just the same. And so that was sort of a kind of a common theme, is these languages are all the same. And I remember at one point I started having these epiphanies, not just how the languages were all the same, but how the projects were all the same. They all had data coming in, people who wanted something of it. And I remember at some point I was working up this sort of this grand unified architecture for everything idea I had of just this sort of way to solve all the, how these problems were all the same, and how, one architecture could solve them all. And I was presenting it to Leslie over dinner one night, and I remember he said, well, this is very APL like, this thing you're proposing. And I didn't know what he meant by that, but I did know it was a compliment. It was a thing I knew about, and I knew it was a background that my colleagues shared, but it wasn't part of the solution of anything we were building. And so I was never really exposed to it. But then at some point we had a project, and the project was basically to store and provide access to and analysis of electrical consumption data for the province of Ontario. And so this was a database that, for 5 million homes and businesses, reporting every hour or 15 minutes or 5 minutes, or the target was every 5 minutes. So this was a database that was going to grow and grow and grow, and we needed to be able to analyze that. And so this was certainly a big data problem. And so, our first engagement was really a research project to recommend a technology to solve that. Leslie, with his IP# background, was aware of KDB Plus and the Q programming language, and we ended up recommending that. He convinced those of us that were working on the project that this is what we should recommend to the client, which we did. And we built a proof of concept and had a bake-off against another vendor, which we won. And so then we were hired to build this electrical consumption data project. At this point, Q is put in my hand, and this problem is in front of me to solve. And really from that point on, I just became a full-time Q programmer, and I basically never went back from that point. Oh, and I wanted to say when unlike C# and Java, when they said, "Oh, this is, don't worry about it, it's the same," it's just the same. When Q was put in my hand, they said, okay, this is not the same. This is going to be different.
In case you didn't notice, just in case.
and it wasn't. Although, at first I was basically writing the same type of code. You can write some pretty Java-ish code in Q, and which is arguably a strength, or it's but it's certainly possible, and I did that, and that's sort of, I think, maybe one of the classic sort of learning curves you have to go through. But at some point we kind of switched from project mode to product mode, and we were acquired, and we started building a product to solve problems like the one we had just solved, and so that was really interesting, and building a sort of a layered product that partners could customize, and doing all of this in Q and KDB, and so we did that. I did that for a bunch of years, and then after 21 years, that job, I decided to make a change and move on, and I took a sabbatical to just kind of focus on some other areas of my life, and I started listening to this podcast in that time, and I knew that because I'd known from all those experiences at Affinity that these languages and that culture was a part of a sort of a greater community. And I was sort of interested in that. So I'd started listening to this podcast. And so through the podcast, I'd heard about the competition, of course, because it had been advertised on there. But also, I found myself listening and strangely having like opinion, kind of like, I don't want to say shouting out, but maybe shouting out at times or whatever. Like I remember, one episode where Conor and Bob, Adam and Bob were debating, whose trains were better, J's or Dyalog APLs. And sorry, Bob, but like Adam ended up convincing me, like I liked the way they work in APL, but I'd never written a train, like, I hadn't heard of one until you guys were talking about it. And so I had this experience of finding myself with strong, passionate opinions about a topic I had no experience in. And I thought, well, this is dumb. So
it works for me.
So I wanted to learn APL basically, and so then I thought, okay, well, the competition would be a great way to do that, and so I actually started warming. I started working on, just sort of as an aside, at one point I saw someone give a demo in Q where they used the Q REPL as like PowerPoint, basically. Like they'd written a bunch of functions that could emit ANSI codes to the terminal, and so they could go through slides, and I think they could run code and then put it in the result up and leave it while running more code, and it was this fascinating demo. And it's like I forget what the topic was because all I could remember was the what was shown. And so I started working. I wanted to see if I could make something like that. So I started doing that, but because this podcast had polluted my brain, I thought, okay, I'm going to try to do that all tacit in Q and write the whole thing with no curly braces. And so I started doing that for a while, and I started convincing myself, okay, I can do this. Like I was getting somewhere, but then I thought this is dumb. It was definitely harder than it needed to be, and what I really wanted to do was play around with APL, and the deadline on the competition was coming up, so I sort of abandoned that project, and then I started on the competition, and we could go into detail on that, but just to get out of my background phase, that's the story from a kid who's never seen a computer to the APL competition.
It was really cool. Well, it was great meeting you in Portugal. I got to see your winners presentation live. That was really fun and interesting. But it's also been really fun here, hearing more details about different parts of your history that you didn't say. There.
Yeah, and for those that we mentioned at the top, but for those that haven't seen that, it is available recorded on YouTube. We'll put a link at the top of the show notes. And it is both your talk, Michael, and I'm going to forget actually, I have it right on my screen here.
Li Tuching.
Yes, the other
student winner.
Yeah, one of the student winners are both fantastic talks that are, great if you're, array language curious and you want to see sort of, maybe not a beginner's, but sort of someone that's new to the language. I can't remember what the other individual also was new to the language, and had some interesting insights and stuff.
I'm glad to hear you say that, because in that presentation, I really, my goal was to be useful to potential newcomers and try to break down what, for me at any rate, I'm not claiming to be expert or anything, but for me, the thinking process of how to, I took one of the problems and tried to show, like, how do you given that the tyrannical, empty text file, how are we going to solve this problem? I tried to sort of break down thinking approaches in a way to get there. So I hope that might prove useful.
Yeah, it's really good if you're looking for that perspective, how to approach the solving of the problem part more so than maybe how you would spell the squiggles. It's really good for that.
That kind of goes back to your original story about your professor who started with, what we need to do here and breaking it down to a computer language. It's consistent with that, isn't it, Michael?
Yeah. And I think for whatever reason, the way my psychology works is I'm just sort of perpetually stuck in beginner's mind. And so, my whole narrative is always like, the first time I did this and the first time I did that, and how, just how exciting it is to sort of learn new things and learn new ways. And
I have a bit of a question there, where because you've programmed in like largely a lot of traditional languages and then more recently array languages, one of the approaches to teaching computer science and programming in the sort of conventional computer science schools is to teach, well, especially like high school, sixth form, college kind of age, is about breaking down, decomposing a problem into the necessary steps until I guess you've get it down to the point where, I know how to express that idea in this computer language. Did you find a difference either in the level at which you would start putting stuff to code, or like how much you need to break things down, or whether you even would break things down in different circumstances? Back when you were solving problems in more conventional languages, and then whether that's different or similar with array languages?
Well, yeah. I mean, certainly you need to break problems down, depending on the size of your problem. And I know a couple of weeks ago you guys were talking about sort of leet code versus like production applications, and I thought that was an important discussion, because I know I've met a couple of people who are interested in this topic but find it hard to like see the cross that bridge from the sort of puzzles and brain teasers into how to build a whole complicated bulletproof production worthy application, and certainly it can be done. So obviously you need to break down a problem like that. I guess I would say one of the things about these languages is often in a traditional way you break it down until you know how to solve it, and then you build up the solution and test it or whatever, and then you get it working, and if it performs well enough then you move on, and or whatever, and that's the process. I find in these languages I frequently I solve the problem 3, 4, 5 different ways, and then pick the one I like the best for according to whatever, whether that might be readability or performance or reusability or whatever. So that's definitely a different process. Related, this is maybe a tangent now, but relatedly, one of the big changes for me too is of course is the workflow, where in that traditional way, I talk about you take an empty text file and you start putting, you describe your problem into it, and then you refine it, and then you get it into code, and then you try to get that text file to, you pass it, get the compiler's seal of approval, and then see what the runtime game looks like. Whereas in these languages, it's kind of goes the other way. It's like which is to say the REPL was a new experience for me, but I am building the code in the REPL and try experimenting, getting it to work, maybe seeing if I can get it, whatever, if I'm golfing it or if I'm whatever it is, I'm like, try it a bunch of different ways. And then when I've got something that I'm happy with, I cut and paste that line into the text file and sort of cement it. Of course, I might come back and change it or whatever, but it's this sort of, I work and test and debug the code till I'm happy with it and then put it in the text file. Whereas in a traditional language, I'm typing code in the text file and then later figuring out whether I'm happy with it.
You were speaking earlier about this is not the same, and also about in relation to Q, not the same as Java, not the same as C#. And you also mentioned that Q has got features which allow you to use what you know in the languages that are the same and get started. And that's definitely one of its virtues, that you can get productive more quickly.
But also it's a trap too.
Yeah. Keep that thought, because that's exactly what I want to ask you about. Because if you approach K de novo, you've got to pretty much grok the whole language before you can get anything going in it. Whereas Q is a soft introduction. So in my day job, I'm particularly interested in the transition to vector thinking, because from one point of view, that soft introduction in Q, the trap that you just spoke of, it defers that process. And as someone who's come through that process with a good deal of awareness, because you've got other programming languages behind you and you've got a lot of support around you at the time from APL vector guys, I'm wondering what your thoughts are about that transition. What helps, what works, what makes it harder?
Sure. Well, I guess I would say that for me, like, it was I had to, the first major thing I wrote in Q I had to rewrite because it performed like I'd written it in Java, and we didn't pick Q to get Java level performance. So to some extent that was sort of, that can be a, if you're on a timeline or whatever, that can be a stressful experience. But I would say, if you were looking for a bridge language, you could do a lot worse than Q. You've got, invoking a function is normal, quote unquote normal. You take the name of the function and then some form of brackets, and then the arguments to the function with some form of separators. Yeah, it's a little different than the traditional C-like ones, but it's the same sort of idea. And by the way, your function can take any number of arguments, including 0. Or including 9 or whatever. So you can and the control structures are the same and or quite similar. And it's funny enough, like where your case statement is a $sign or something like that. It's syntactically different enough that it's feeling exotic. And that's part of the trap, I think, is you think, I must be doing this right because I figured out how to use each. But really, you're just writing loopy code, or whatever. So, but it is sort of a soft landing, and then one of the first things that it forces you to contend with is the change in precedence rules, and which is sort of magic. Like, to me, like getting away. Losing bed mass and all its, and the extension, it's like taking a weight off that you didn't even know you'd been carrying for decades, having to remember those things. And like people, bed mass isn't that hard, but when you start getting into logical operators and bitwise operators and pointer dereferencing and how to remembering what order, just how to parse this, you have to look it up in a table, or devote a lot of your brain to memorizing it and running it through the table you have in your head, versus just scanning the line, just reading it or writing it is such a great experience for me. Like that is such a magical thing. So the new programmers, like the programmer coming from a classical background and encountering Q they have to learn that. And that's a great, new thing, a great new experience. But of course they can still write this loopy code or whatever. I guess, for me, I'm not sure exactly how to get over that next hurdle. But when you do, I mean, for me, it turned my thinking inside out. Figuring out how to write code that solves the same kind of problems you're used to solving, but having it look so different is, I mean, it's a great experience. It's a challenge. I think, a lot of that is sort of done historically through apprenticeship, word of mouth, oral, verbal storytelling or whatever. But for me, like, the main concepts you got to wrap your head around is sort of getting rid of the outer loop. You want to push the loop further and further into your code until ideally it disappears. Or if it doesn't disappear, you've got you're looping over the smallest possible thing. So, a classic sort of anti-pattern I would see in Q is a big lambda each over the things you want to do it over. And it's you may need an each in there somewhere. It's not that, you may need to do something with a primitive that isn't vectorized or a function that isn't vectorized, but you want to get that each into, so it's just over the things that need an each. And so it might kind of feel weird because you might need 5 or 6 or 7 eaches potentially if you've got, if this is a big lambda thing you're doing. But the point is, because once you have a big outer function and a single each over that, you've lost the opportunity to use, the vectorized functions, any vectorized functions that occur within that lambda. So that sort of that process of pushing your loops, deeper and deeper into your code until hopefully they evaporate is that's a kind of, it's almost like a literal inside out thinking compared to the way I'm used to. And then same with branching too. Like I used to have in the traditional coding world, I had this sort of almost visual intuition to what a solution to a problem ought to look like. It's okay, this is going to be a for loop with a condition, where I'm going to iterate over the items, and then I'm going to test some condition of interest over each of the items. And if the condition is true, I'm going to do this with it. And if the condition's false, I'm going to do that with it. So it's going to be some sort of double humped for loop kind of thing. And you would just know, and if maybe the problem's more complicated and it's a quadruple humped double for loop or whatever, but I would just sort of instinctively know what the solution for a given problem ought to look like. And if I opened up a piece of code and it didn't look like that, I'd think, I bet you something's off, and often I'd be right. And it was this sort of kind of gut sense thing that I had. But of course, in these languages, you don't do the branching either, right? Or you try, generally, Q supports that sort of thing. But generally, if there's a property of interest over the things you care about, you compute it for all of them at once in one thing. And then you do whatever you want to do to the ones that have the property, you do it. And then you do it, whatever the other thing, to the ones that don't. And so it's just sort of a 4-line, it's just 4 lines. And you don't need, well, what if there's none? What if one of these sets is empty? You just do it anyway. Like it's, you just, because it ought to all fall out, and it's really quick to whatever, reverse a vector with nothing in it.
Michael, when you moved when you moved over to APL, did you already have, was the epiphany fully formed from working with Q, or were there other things that you found when you moved to APL that you suddenly thought, there were areas of Q that you didn't like? I guess, is APL more revealing to this process, or did you get it all from working with Q, just in a different paradigm?
Well, no, APL is definitely revealed more. For sure. I mean, I was, because I had the experience of learning Q with veteran APLers, I think I kind of got a lot out of it. But so, I was definitely coming to APL with a leg up for sure. And I had started like, or certain things were sort of took me further or refined it further. Like, so tacit, I know there's tacit in Q. It's limited compared to APL, but there was some tacit stuff, and I had encountered some of that in the wild, but it wasn't really, wasn't really on my mind. It's a podcast that really just made me aware that it was a thing to have an opinion about or whatever. But I had started to embrace the terseness. Of course, Q is, less terse than APL, but it's still pretty terse compared to Java and very terse compared to how Java is frequently written. But one of the things like, that I did in Q was there's a primitive in Q called enlist, and it's not the enlist in APL. It's the enclose from APL. And this is something, you use all the time. This is a very common thing to want to do, to basically turn a scalar into a list, or a list into a list of lists with one item or whatever. And so it's such a basic thing that you want to do. And I found enlist, 6-letter word, often taking a variable afterwards, so needing a space, too long. And so one day I'd had enough. I think I was maybe working on a weekend or something, and so I felt a little more free to pursue something that a personal pet peeve. And so I added to our utility library, a shortened version of it, ENL, for enlist. And I just, sent an email to the group. I couldn't take it anymore. I did this. Let me know what you think. And the group actually adopted it. But the way I implemented it was as a lambda, as a function, basically curly brace enlist X, close brace. So as a function who passes its argument to enlist and returns that result. And then at some point I noticed Leslie, because I'm a diff reviewer, by the way, I noticed that Leslie had changed it. He changed the implementation to enl gets enlist. So, which is, sort of like, duh, you're just creating a synonym or whatever. But at the time, it kind of blew my mind. Like, oh, I can, it's sort of the most basic tacit definition. It's the degenerate tacit case, arguably, but it blew my mind, and that sent me on a whole new way of like working. Functions as first class citizens is a great feature of Q. And I'm sorry, Bob, I know your question was about APL, and I will steer it there, but this idea, all of a sudden realizing, like functions as data, like that was a big kind of mind expanding moment for me, and the stuff I could do in Q, and with its terseness, I could build tables in code, like literal tables, and put functions as members of the table, and have it shown, like drawing that in code as a 2-dimensional array, basically, then have that control the flow of the program, and just like really, really different, interesting stuff. But Bob, you were asking about kind of going to APL, and so certainly tacit was what brought me there, an interest in it, and then obviously rank is a different concept, and so those were good to play with.
But I guess on the other hand, the thing that you lose is the higher order functions, right? Because I know BQN has that, but J and APL do not. Like
the first class, like functions as data.
Yeah.
Like putting a function in an array specifically is one that you just Well, APL has these things called fun arrays, but they're really weird. You have to create them from namespaces. I mean, they're not the same at all.
Right. Yeah, they're not. Yeah, and it is probably when I'm programming an APL, that is the thing I keep reaching for. And yeah, I put stuff in names. I know they can be kind of values of namespaces in a sort of dictionary kind of way, and there's some stuff you can, there's classes, so there's like ways to encapsulate functions that are useful.
Yeah, I mean, why do you have to encapsulate it? I want the function.
Right. Or putting two functions in a pair and then using, a Boolean to get which one you want out of it, and then just executing that or whatever. That's a really nice feature of Q. But I did, if you don't mind, I did want to talk about the sort of I did have like one of the aha moments I had in APL, at least with tacit, which I know is maybe a controversial topic for some people. But when I got to the competition, tacit was well, and the sort of my personal history, but the idea to play with tacit is what said, okay, I'm going to do this now. And so I got to the competition, and there's the phase 1 problems, which are basically 10 one-liners. And my initial goal was, okay, I'm going to do all of these tacit because that's why I'm here, which I failed to do. Or there's some of them were just got hairy enough that I just needed the safety of arguments, basically. But I did. But one of them. But I also. Okay, one of the questions, you had to write a function that basically looked, two lists of equal length and how many were not the same. Well, like if you line them up, compared 1 to 1 and 2 to 2 and 3 to 3, like how many differences were there? And so which is basically sum not equal. And so that's a pretty Q, like that was comfortable. That was easy. I knew how to do that. It was just a two, like I guess it's called a two train or whatever. Like it was just, that was pretty easy. But the next one was it was like given two arrays, return a list of things that are in one, like just one array, but not both. So what are the list of things that are in either one, but not both? And so, I worked, like I, thought about that, and I tried it a few different ways. I'm sure there's a lot of ways to solve that problem, but I came across, the solution I used, which was union without intersection, tacitly. So just union without intersection. And I just thought, union without it, not a function that takes its arguments and provides, and passes its arguments to union and then passes it to intersection and then computes, passes those results to without, not that function, just union without intersection. And it's like, to me, it was like, oh, this is like a line from a haiku. It's like a metaphor for marriage or whatever. Like, it's just this, it's like, there's something to me that was kind of poetic about it. And I thought but
it's got 8 syllables. So
yeah, I know. And the more I looked at it, and if you look at it, it's the union symbol is sort of like a wide symmetrical U, and then tilde, and then in intersection is that inverted, and it's very kind of beautiful, and there's symmetries to it. You rotate it 180 degrees and it still says union without intersection. And if you like reflect it on either axis, it says intersection without union, which is, I don't know what kind of means. I don't know what that means, but it's just going
to be an empty result, I guess.
Yeah. And that was kind of interesting. And then if you zoom in, like the tilde, if you look at the tilde, it's sort of union and intersection fused together horizontally, so it's like a fractal, you go in and there's just more of it. And so this was, for me, this was like, oh, like I kind of clicked, like the appeal, the sort of mystique, or the why this is sort of, for me at any rate, interesting. Like it was aesthetically pleasing, And so that was really interesting to me. Although I'm not sure that I'm a huge like tacit guy. Like as I went on, especially as I got into like phase 2 of the problems, where I was needing to solve bigger problems, and I would find myself like, I can't tell you how many hours I like, battled the interpreter to build a tacit expression for what I was trying to accomplish, and succeeded at great personal cost, and then ultimately decided this is not to me, to my taste at this moment in my experience, did not seem like the best way to convey the idea, or the way, if I came back to it and needed to refine it, fix a bug or whatever, what I wanted to come across, or to, if I needed to debug it. So I wrote in the competition, I wrote a lot of tacit stuff that was not in my submission at the end of it. But I was really there. I wasn't really trying to win. I was using trying to win as a way to learn APL. So I certainly succeeded in that, or getting a feel for tacit at any rate.
Can I take you back to what you were saying about learning and apprenticeship? And you spoke very warmly earlier about pair programming.
Mm-hmm.
I reflected some years ago that pretty much all the APL I'd mastered or learned, I'd learned really from somebody or from working around people who knew stuff. I learned the language that way in the first place. And this is kind of a bit of a sideways jump, but as a young man, I converted to Zen Buddhism, which distinguishes itself amongst the Buddhist schools as a direct transmission of the Dharma, of the truth, from one heart to another. It's pretty much the basis of all the teaching I've done successfully has been based around pair programming. I was first trained as an APL instructor by Ken Iverson, using his working introduction to APL, which was basically teaching people in pair programming before pair programming had a name. And when I reflected some years ago how working from home and being dispersed around the world was kind of isolating me from all the great colleagues I used to have, from whom I was always learning stuff. Oh, you're doing that, we started a series of, I don't know what we call them. They were kind of week-long APL house parties, or array language house parties, which we called Iverson College. We started that in 2011, just to get people back in working in the same room again. And people come from all around the world to spend a week doing their work in the same room, so you could kind of talk about it afterwards. So this is a challenge for me. A standing challenge is getting people over that hump you're talking about, from what Joel Kaplan on this podcast called the one potato, two potato approach, to thinking in terms of vectors. I don't know any more effective way of doing it than really just like one-to-one pair programming, as you described it. And unless I hear of a better way, if I can hitchhike a ride on Passing Seagull up to KXcon in May, I hope to be there and do what we call the Vector Dojo and set up that kind of pair programming so people can experience it. So that's my thinking. I'm wondering if you can help me on that in any way, or ideas or whatever.
Well, I completely agree. I mean, I think, I had, that experience I had at the AI lab at U of T, so there's a lot of pair programming in that. And then basically pair programming with Leslie at Affinity for, the start of my job there, completely made me who I am, completely taught me how to be a programmer. And, whether you're trying to learn array or, how to internalize the keystrokes of Vim or whatever, like it's just such a way to connect with a person and learn stuff. And it's so tailored to the to the person. If they don't get it, you don't move on. Whereas, a video or a book or a class, doesn't work that way. And so, you can, so yes, to some extent, I would say, Zoom, like there's certain physical sharing, two office chairs at one desk and one monitor is sort of physically awkward. But other than that, like the human connection from being in the room, talking, eye contact, real eye contact, not via a camera, waving your hands, like just all that, interpersonal experience, I think is can't be beat, like as an educational, as a way, and especially when you and for a code base too. We're sort of talking about languages and tools, but also you often have a code base, and to be given the tour through the code base. Let me walk you through this, let me show you, search for this and these files or whatever is just a really great way to sort of hand off a code base as well, or to bring someone into a code base.
Well, maybe we'll both get to KXcon and be able to do something there.
All right. I have a list of like 7 things I need to ask/say. Because this is, the first thing I'm going to say is one of the most recent movies I watched in theaters was Avatar 2. And like, this is like 10x, 100x better. Like I've said it before on other podcasts that like, I don't know, listening to this kind of stuff, it's like better than sports and like entertainment and Marvel movies for me. Like hearing you talk about the poetry of the intersection union without, it's just, it's going to be great. I can't wait for our listeners to hear this, because these kind of conversations, I just have to, I was a couple times going to interrupt and ask a question, and then Bob would ask the question. I was like, you know what? I'm just going to treat this like I'm at a movie experience. But so I guess I'll start with my most recent thing that I want to say, because we were talking about pair programming. I think one of the things too, like that makes, because I've had good pair programming experiences and like less good, and the best ones are the ones where there's like a complete amount of like mutual respect between the programmers. Not in that like the bad experience I've had, there's been a lack of respect, but it's more like you are not worried that asking a question is going to come across as like that I don't know what I'm doing. And I think that there is a ton of that today in the industry, because salaries have gone up, or, a little bit of shift happening in the industry right now. But like, I think a ton of people are completely afraid that if they do that kind of pair programming experience, like day to day, we're fighting with compilers and trying to figure out how things work. And people are very concerned that if people saw the way they worked, that they would be exposed as a fraud, when really that's what we're all doing. Like I've talked to some of the most senior people in the industry that work at companies like Apple and Adobe, like executive senior people that still do technical work. And I remember one time, I won't say actually, I think he'd probably totally be fine with me saying this, because I might have said it in some other context. Sean Parent, he works at Adobe, extremely senior, luminary of the C++ world. And I remember having lunch with him at a conference once, and then he was telling me about this project he was working on, and he needed to Stack Overflow, how to get some like Apple hardware to do. And I was like, wait, what? Like, did you repeat what you just said? Did you say you were on Stack Overflow? Like, my view of this individual is that, he's this kind of godlike figure that lives in the clouds. And, they tell stories of him, how like he just sits there for 4 hours without writing anything and like programs it in his head and then puts it down on the screen and it just compiles, because he worked out all the bugs in his, anyways, that's like the stories that they tell. And then you have lunch with him and he's like, oh no, yeah, I was, I found some Stack Overflow posts. It was like the third answer that actually did it. Anyways, the point being is that I think pair programming, there's not enough companies that do it. And I've even at certain companies have tried to suggest it, and managers are worried it's going to lead to like less efficiency because there's 2 people doing the same job. And it's a real shame, because there are other companies that it's their bread and butter. And if you go into it knowing that like, we hired you because we think you're smart, no question is stupid, there's things that I'm learning every day and everyone's learning every day. Anyways, that's my little bit on pair programming.
Sorry, can I just jump? I just want to say one more thing about pair programming, which I'm not sure if I used the word before, but I think it's really important, which is that it's fun. And like the laughs. Some, like at Affinity, we would, this might be more in a whiteboarding session than maybe a pair programming thing, but like if we were trying to solve a really hard problem, like someone would always very dryly throw in a ridiculous suggestion for how to solve it, like a really, really bad way to do it. And it would be so fun. And every once in a while, that would actually spawn some sort of lateral thinking that would open up some new possibility that you hadn't occurred with. But just fun and laughing with your colleagues, is motivating and creates loyalty. People will stay longer somewhere they enjoy working. That's sort of pretty basic stuff there. But at any rate, so yes, pair programming is awesome and fun and super useful. And that whole concept of like egoless programming, which I think is part of what you were getting at, not being afraid to look dumb, or, we want the best solution, not, for people to think I can do the best solution.
Yeah. It's like, I recently posted a YouTube video, and I'm a Rust beginner. Like I've just started learning Rust, or maybe for a few weeks now, but I made some mistake that, a ton of people, some people are really nice about it, but other people are just like, oh my goodness, like this is, and I'm, they're trying to be kind of like harmful, but I'm just like, this is perfect. I put stuff out in the world, people tell me, and like, who knows when I would have learned that, but like now I learned it faster because like, honestly, like good code review where people are pointing out mistakes or places where you can do something better. Or, oh, hey, did you know that there's a convenience function where you can spell it, 6 characters less? I love that stuff. And it's fantastic.
There's I think in like musician circles, or certainly jazz musician circles, like there's a theory that like you always want to be the worst player in your band. Mm-hmm. That's how you get better.
Yeah. I think, why is his name eluding me? Chris Latner, the individual behind Swift and Clang, LLVM, and a bunch of other projects. I think that's one of his like quotes that you can hear him on different podcasts, is that he always is searching. He was at Apple for a while, then Google for a while, doing TensorFlow for Swift stuff. And if you listen to him on podcasts, he's always saying that like whenever I feel like I'm not at the bottom of the totem pole in terms of some technology, like I want to switch because I always want to be learning from people around me, which I think is amazing to hear from someone, that senior in what he's been doing. All right. I got a couple other comments and questions. First one is another plug. I plugged this on my other podcast, but so we brought up the poetry, and the podcast is Oxide and Friends. It's by a guy named Brian Cantrell and friends. And it started out as him and some colleagues of his. I think a lot of them used to work at Sun Microsystems. I know Brian did. And I think Steve Klapnick, who I might be pronouncing his last name wrong, he's one of the co-authors or main authors of the main Rust programming language book. They have an amazing podcast. My favorite podcast of all time is Functional Geekery. And I recall I was working at Amazon at the time down in Silicon Valley, and I would go for these runs at lunch and just like crush these podcasts. And I learned about Elixir for the first time, and Erlang for the first time, and F# for the first time, and just so many of these languages that I'd never heard of, because at that point I was just a C++ programmer that knew a bit about Haskell. And it was just I remember that time so fondly because I had 120 episodes to go back and I could just like listen to them in a row. And I'm having the exact same thing this time, going back and listening to Oxide and Friends. The reason I bring it up is because on 2 different episodes, a couple apart, I'll find them and put them in the show notes. Brian Cantrell, who some of people might not know by name, but is the individual that had an article interview with Arthur Whitney. And so Roger Huey, I think when he passed away, they mentioned his name on the podcast in the episode that was close to that time period. And then a couple episodes later, they mentioned that at some point, I think during the interview, and it might not have made it into the interview with Arthur Whitney, Brian Cantrell asked him, what do you think the best analogy for programming is? Is it, some management system or et cetera? Like if you had to choose like sort of an analogy, what would it be? And Arthur Whitney's response was poetry, which I just thought was fantastic. So anyways, folks should go listen to that podcast. And I guess I'll skip a couple of the other things, and maybe we'll have a behind the scenes where I can ask these later because I'm going on too long. I think this has sort of been answered here and there, but maybe not directly. So I just wanted to ask explicitly in case if there's anything that's been missed. I know when we talked back in September in person, you were talking about sort of the things about Q that every once in a while when it would come up, you'd be sort of those moments where you'd be shouting, "Oh, I hope they mention this," and that sometimes we hadn't mentioned that. I think putting the functions in a sort of a pair of functions and then executing one, and a couple other things you said. But are there other things about Q that sort of you want to tell the listeners about, like things you might appreciate in the Q language that aren't possible in the other array languages, or that are more ergonomic? Just that, in case there's something that hasn't been mentioned that you might want to.
Well, yeah. I mean, I think the main the thing, the event you're referring to, that was definitely being able to put functions in data structures and use those data structures as sort of ad hoc control structures for your program. So, which I know, I think, Marshall, you mentioned that when you were talking about BQN and the control structures episode. So that to me, that is like a big feature of Q that I use a lot, and for example, in a classical thing you might do in an application is you've got these events going off or messages that arrive from some upstream whatever. And the first thing you got to do is, okay, you deserialize it, or you deserialize enough of it to know, like, what sort of thing do I have? I mean, in Q you've deserialized the whole thing, I assure you. But you so in C++ or whatever, then what do you take this thing and you look it up in a big switch statement. Typically, this is the code I would write. You look it up in a big switch statement, and it's sort of every line is a, if it's a this, create a new this spelt differently, and then call do on it, So I've got a foo message coming in, so create a new foo message object, populate it with the byte stream that's coming in, tell it to finish deserializing, and then do itself, do whatever the programmer said we should do when a foo comes in. So just being able to like index, if those literals that tell you what type of message it is are dense set of small numbers, you can just literally index into an array of functions and just go off and running, and it's so fast, and it's such a clean way to construct something like that.
Yeah, so I've done that a bunch of times, and one of the other cool things about it is that you don't have to have just one function. You don't have to have just a list of functions. You can even have a table of functions where one of the function processes it. Maybe even you have another function to deserialize or something like that, or another function to tell you some property of it. All that kind of stuff. So you can arrange your whole program very nicely into a big table of functions where you've got the type of element and the thing you want to do.
Right. And it's often like, it's sort of, it can be a multi-dimensional, like here's the pre-processing, processing, post-processing we want to do for each of these types of messages. And so that's sort of a 3x(n) table. And each entry in that might actually be a chain of functions. So, where each function, if by convention returns, its input, or possibly modifying it. So, you might say, look, pre-processing, I want to confirm that the sender had the right to send this type of message. I want to audit it. I want to log it, whatever. And so that's my pre-processing chain, which I can customize by function. And then I go into, processing. And so you end up with these sort of control cubes. And then the outer code, the top loop that runs your program is just sort of like, take the thing and, find the cell and run it, run it through the function. So that is, to me, really, really neat. And then with the terseness is, I think I mentioned this earlier, but I would literally, someone, by the way, apologies for tooting my horn here, but someone once told me that, he'd come across a table I'd written in Q, like a literal table. Like I was using code to create a constant table, basically. But I draw it like a table. I use whatever the separators between the rows and the fields in the rows or whatever, like they'd be like the pretty little boundaries of the table or whatever. And they said it was the nicest, table they'd come across, in Q. So I felt very pleased by that. That was a former guest on your show, actually. But but then like in the cells, you can get a lot if you're doing something like that. You can put a lot of information in the cell because it can be so terse. So you can really just kind of get this bird's eye view of the program, and just this in a non-linear, the code file with this non-linear representation of how the program works is kind of neat.
And I guess we can point this out as one thing that APL is trying to remedy. I don't know if Jay has any plans, but this array notation that Q has, you've got your brackets and you put all your stuff in the middle, and you can use either semicolons or new lines as a separator. This is pretty similar to what Dyalog is starting to roll out, sort of as an array notation, but you'd still be missing it right now in APL.
Yeah, there's some history behind the development, but Adam is working on a more official proposal to send around the APL vendors and other community members who might want to have a say, so that if we implement it as an actual language feature, we're not going to make a horrible mistake and want to go back later and regret those choices.
And there's certainly been discussions on the J forums, but I think most of it reverts back to gerunds, which I'm not sure is the solution we're all looking for, but often that's held up that way. But it's being discussed.
Well, Conor, we've got another guest here who's absolutely haunted by aesthetics.
I was when you were telling the ENL enlist, I was like, this supports like whatever I was saying a couple episodes ago, like so much. It's that like for these, and that's the thing. It's like I know that there's people, maybe not the listeners of this podcast, but I'll talk to programmers at large at different conferences. And if you've listened to my other podcast, Bryce, at one point when we were having this discussion, he was like, what did characters ever do to you? Like, you're so against the character count. And I just said, like, for primitive things, it's like, who wants to go around writing 4 infix PLUS, and then, 3? Like, it's for something as fundamental as addition. If you're using it, especially in a domain where it comes up all the time, like, it hurts my soul to have to, write, in C++, it's std : PLUS. It used to be bracket int end bracket paren. With C++ 17, we got rid of like 5 of those characters, but it's still like it's plus. It's math. It's plus. And like Haskell, you can do it 3 characters. I think in Q, with the parens, you can do it with 3 characters. And in certain languages like Lisps, you can do it just with the plus. And it breaks my heart when, like, especially when you experience that experience. It's like when you said, when you go to APL from Q and you're used to be able to do something a certain way, and then you don't have that convenient tool that you're used to being able to grab. It just it's sad. And yeah, some people will say, it's a silly argument, but I really do think that there is like the brevity with which you can express yourself and subordinate, syntax and details that don't matter affects the way that you write code and the way, like you said, all of this at the end of the day, it's fun. Like it is when you write that 3-line, solution every once in a while, you're like, it's so beautiful. Why would I ever want to write this any other, like it's yeah. Anyways,
to be clear, to clarify, I think there are 2 things we're talking about here as well at the same time. One is the ability, functions as first-class citizens that you can put into array structures and then do array manipulations to choose which functions to apply on your arguments. And then the other one is a literal array notation for in your source code, like writing, literally an array rather than having to construct it from primitives like you have to do most of the time. Just want to clarify that Dyalog's not putting in functions as first-class citizens in case someone got that idea from the way the conversation went.
I can't leave this one alone. We have a 3 Canadian episode here. I'm going to quote another Canadian. So, I came so far for beauty, and I left so much behind.
I have no idea who that's by.
That's Leonard Cohen.
Oh, really?
Yeah, Leonard Cohen. Oh, I don't think we're in Leonard's league, but he can always aspire.
I did want to, but on the topic of maybe poetry, but certainly brevity. Like to me, like there's one of the arguments against brevity is a claim that it is it's opposed to readability. And I just wanted to, argue the other side of that for a moment and say, I find that, one of the great things about these languages, and certainly, going from Q to APL, was that there was another sort of gear of brevity I could get to, and that you can. What I find is that, okay, two things. So one, for example, what in a traditional programming language you would, might take a paragraph or a half page or whatever, font size, these things matter, but a big chunk of code can be one line of code. And so, yes, it's, you really need to you kind of have to change your focal length if you want to see what's going on there. But you can get it on one line, and then you can, and usually with enough space left over that you can have a comment to the right of it that describes what not how you're doing what you're doing, but what you're doing or why you're doing it. And something about being in that sort of terse mindset makes me want to get that English comment as succinct as possible, as simple as possible, but no simpler. What is the poetic expression of why I'm whatever it is you're doing, you're going to take the first and add 7 to it and blah blah blah. You're doing something, and some people might argue, well, the code is self-documenting, but I always think there's this other level where you're why you're doing it or what business problem you're solving, translating this into some other way. So you've got these sort of like two parallel narratives that are going on, which is the code and the comments, and that brevity kind of creates space. So rather than interspersing them, you can have them side by side, which is can be really useful. Like when I would, in the competition, when I would find a bug in something I was writing, I'd scan up the comment side of the code to figure like, okay, I've got a parsing problem here. So let me go find where I'm doing the parsing, and I can just go up that right-hand side, find that, and then switch back over to the left side of the code, to figure out where the bug is. So, and because things are so compact, you can do other things that I just wouldn't really think to do in other languages. Like, for example, this is sort of non-standard styling, I suppose, but I will introduce a space somewhere where typically you wouldn't, if you think consistency is king, you either put spaces around binary operators or you don't, and then that's just the way it is. But I would do things like I would put a space if I've got 2 lines of code and they have a relationship with each other, if they're mostly the same but slightly different or something like that, I will line it up so that the similarities line up and so that the differences line up, so that you scan it and you see immediately, oh, this is subtly different but importantly different. And if that's one of these double hump for loops, or something, you're not really going to be able to see those differences. But in these array languages, you can do that kind of thing. And so there's a different type of readability that's that you get with such short, all these, where the whole standard library, is 1 character each or whatever. There's just different opportunities to play with style and readability in ways that are not just pleasing, but I think like useful, like add more clarity.
It's I mean, and you articulated this so well earlier, and that was one of the things I was thinking in my head is because it's so terse, you take the paragraph and you put it on a single line. And you mentioned earlier that presents the opportunity to solve it several different ways. And specifically, you pointed out that there are different motivations. Am I going for performance here? Am I going for refactoring here? Am I going for the ability to parameterize this and reuse it somewhere else? And I think that's a lot of people, they miss that. I gave a talk, Algorithms as a Tool of Thought, that was the whole point, is that I showed like 9 different ways to do this one short, simple problem. And it's not about that, like, I'm going for the fastest one. I did do a performance analysis at the end, but like sometimes, like, one of the ones I always run into is whether I'm going to sort a list, and then if I'm doing an n-wise reduction with a non-associative operator like subtraction, so I'm taking the difference between an increasing list of numbers. If I want to do the opposite, where I'm sort of I want positive numbers instead of negative numbers because that's a property of subtracting, a left number from the right. I can either apply the self or the commute operator to the minus in APL, or I can just reverse the list after sorting it. Or I could even try and get some sort function that passes it a custom binary operation with, or the two different grades or whatever. Like there's very quickly 3 different ways that I can take my initial sort of two n-wise reduction with subtraction after sorting a list in APL. I can add reverse, I can add commute, or I can switch the grade operator. And it's not like, oh, well, the performance matters. Sometimes, you're working with people that don't like the combinators and they don't want to see a little selfie squiggly and be like, what is this doing to my binary operation? Sometimes reversing after sorting is going to be more readable for folks. Anyways, it's just the ability to do that in APL or array languages is something that is not impossible, but like you can't rewrite something in C++ that's a single line in APL like 3 seconds after you finish writing the other one. It's going to take you like a few minutes just to go and find the library with the function in it that doesn't require for you to use for loops and stuff like that. Yes, this is getting to approaching the record of longest podcast recording. On that note, then, any final questions? For Michael, is there anything that we haven't covered? I feel like we should just bring you back because we didn't even get into the contest side of things too much. You gave us a couple highlights, but I feel like we could continue this for like a whole other hour or two if we had the time. But any final things you want to sort of say or mention before we wrap this up?
I was thinking as I was preparing for this, I thought, one memory I had was when, we had a PM, like a project manager who worked with us, who was just such a great guy to work with. Like he would literally at times, he was non-technical, but like would sort of roll up his sleeves and become the guy that knew how the extraction tool for the data migration project worked and operate or whatever. So he was like, he should have been a programmer kind of thing. And I remember at one point he was asking me, he understands that there's different, it's a different way to think or a different way to program, could I help him understand what's different about it? And funnily enough, I also used potatoes in my example. And it was something about, I said, okay, like, I used a cooking metaphor, and I can't remember. It was mashed potatoes or boiled potatoes or something. I said, look, if say you were making boiled potatoes, and the traditional way to do it would be to like, you take your potato, you wash your potato, you peel your potato, you boil your potato. You grab the next potato, you wash it, peel it, and boil it. And I said, but in Q or in these array languages, you would, wash all your potatoes, peel all your potatoes, boil all your potatoes. And he said, oh, great. That's I get that. That's really helpful. And then I said, but wait, there's this other level that I don't think I'm at. It's like I'm striving to get there. That's why I keep pursuing this. Is like there's this other level where you boil your potatoes and you filter it for skins and dirt. And that's where we're all trying to get to.
All right. Well, I will start to wind this down because I think we've probably hit the record here, but definitely thank you so much, Michael, I know we've been trying to schedule to get you on for a while ever since you won the contest, and the wait was well worth it. And yeah, I can't wait for our listeners to hear this episode because I think they're going to absolutely love it. I will throw it to Bob to let people to know you can contact us at
contact@arraycast.com. And we are always listening. People are coming up with some really good suggestions, and we are pursuing those. MATLAB may be in the future. And also we've got, I think, J's schedule coming up because we've got the new version of J coming out, I think, sometime in February. Not an announcement, but just letting you know you can reach us at contact@arraycast.com. And we look forward to your interaction.
And as always, if you want to, like we've mentioned a couple times now, Michael's talk will be in the show notes. Other resources are you on? I'm not sure if you're on socials or anything like that where people.
Not really. No, that the talk would be the best they're going to find.
If he's not on social, that means we're just going to have to bring him back. So subscribe and you'll hear the next one whenever it's out. But once again, thank you so much for coming on, Michael.
That was my pleasure. Thanks for having me.
And with that, we'll say happy array programming.
Happy array programming.